Hello everyone. We are going to begin our lecture now on the measures of central tendency. That is the different measurements that we can take on our data. Now previously we said that in statistics we have to begin by collecting data, right? So the first step was to collect data. And where do we collect the data from? From our sample, right? And we also said that we cannot work with the entire population to which our study pertains. So we have to draw a sample from our population. And from that sample, we collect data by sending out surveys or setting up an experiment. Uh, but we collect the data from our sample. All right, and once we collect our data, once we get the data usually comes to us in a very disorganized and random fashion. So the next step, we have to organize the data. All right, and we learned all the different ways we can organize the data, whether it's quantitative data or qualitative data. We have to first set up frequency tables. And then once we have our frequency tables, we can graphically represent our data uh, through charts, through pie graphs if it is qualitative data. And then what else did we learn? Histograms and stem and leaf diagrams and dot plots and all that, right? Now, once we have organized our data, the next step is to take measurements on the data. So we start measuring our data. So in this section, in this chapter, we are going to learn what are the different kinds of measurements we can take on our data. And then we'll start with the measures of central tendency. That means the measures that pertain to the central point of an arranged data. All right, so that's what we are going to talk about in the next few slides. Now, the three measures of central tendencies are the mean, median, and mode. The mean is nothing but the average of a set of data, right? And almost all of us know how to calculate the average. The mean, the calculation of the mean is going to be the same as calculating any average. Only in statistics, instead of saying average, we use the term mean. The median is another measure of central tendency. It tells us the value that occurs right at the center of an arranged data set. All right, so it'll tell us the value, the data point, which occurs right at the center point. So if we have a median value, then 50% of the data will be to the left of the median and 50% will be to the right of the median, right? So that's what the median is about. We learn how to calculate or how to find the median. And the mode is the most frequently occurring value. The most frequently occurring value. That's what the mode is about. Mean, like I said, is the average of the data set, right? The mean of a data set, which is nothing but the average, is the sum of the observations or individual data points divided by the total number of observations or data point. So when somebody asks you to find the average of 5 values, let's say if we have 2, 3, 7, 8, and 6, all right, and somebody asks you to find the average of these values, what would you do? You would add up all these numbers, and then we have 5 numbers here. You would divide it by the number of data points we have here, in this case 1, 2, 3, 4, 5, and that would give us the average, correct? So it's going to be, let me just do it, it would go 2 plus 3 plus 7 plus 8 plus 6, right? And then divided by, how many values do we have here? 5 values divided by 5. So how much would that come to? 7 plus 3, 10, 8 plus 2, 10, 20, 26, right? So 26 divided by 5, you would divide 26 by 5 to get a value of 5.2 probably, correct? So that's how we find the average, and we use the same process to find the mean of a data set. Now, while we are at the mean of the data set, let me just write the formula and explain the formula for the mean. All right, it'll do, the formula does the same thing as what we did here, except that the notation will be like this. There's going to be this Greek letter sigma. All right, it's the Greek letter sigma, which is the equivalent of the English letter S. All right, so sigma, and sigma in mathematics refers to summation. All right, so that means you are summing all these different values. So data number 1, value number 2, value number 3, value number 4, value number 5, if you want to indicate which position they are in, and we'll just call them in general X. All right, so each of these, this one is perhaps x sub 1, x sub 2, x sub 3, x sub 4, x sub 5. We can keep going, and we can keep going as x sub j and so on. So when you have to sum up all these values, and that would be summing up all the different x values, one in position 1, position 2, position 3, denoted by the subscript j, and then you divide it by your total number of values, the total number of values, observations, or data points, which we denote by the letter n. N is the same as the sample size. Remember, what we were doing when we were working on frequency table, we were summing up all the frequency values, and the sum of all the frequency values was denoted by the letter n. All right, that tells us how many values there are in our data set. All right, so frequently I will be using this formula. Mean is sigma x sub j divided by n. Now, a few other notation while we are at it is that the mean itself, to denote the mean using a symbol, the mathematical symbol for population mean is this Greek letter mu. Again, it is the equivalent of the English letter M. All right, so mu equals, we can write it as sigma x sub j divided by, now if it is the population mean, then we use the capital letter N. If it is the sample mean that we are talking about, that will be denoted by this notation. Sample mean is x bar, x with a bar over it. All right, and then it's the same formula, but it'll be sigma x sub j, and then the n will be a small letter n. All right, a lowercase n. So again, let me write next to each which one we are referring to. The Greek letter is used for the population mean, and the English x bar refers to the sample mean. The sample mean. All right, and we will be referring to mu and x bar and these formulas frequently in the course of our lecture later on. All right, especially on in the course of the next few slides. So here we are presenting the steps to calculate the mean, and explaining inwards what it is. So it'll be the same thing as what we discussed in the previous slide. So to find the mean, step one is to find the sum of all the individual data points or observations by adding them up, right? So in step one, we do sum our x values, the individual values of our observations, so sigma x, and then in step 2 we divide the sum obtained in step 1, which is this one here, right? We divide it by the total number of observations, and we'll call that n. All right, and again, the formula here inwards is mean, and I'm going to use the population mean notation first. So mu equals sum of observations is denoted by sigma x, and total number of observations would be um, let me just redo this with a little bit differently. All right, it'll be divided by n if it is referring to the population mean. If it is referring to the sample mean, then the sample mean is denoted by x bar, all right? And then sum of observations is still sigma x, and total number of observations is denoted by the small lowercase n, right? Now here is a simple example on finding the mean. It says given the following data set, what is the mean? So the values given to us are 5, 13, 9, 7, 1, 9, 2, 9, 11. And we have to find the average or the mean of these values. So we have to first sum up all these values, which they have done here. They've added all these numbers and come up with a sum of 66, and the number of data points, which is going to represent our n, the sample size, in other words. How many do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, right? So n, the number of points, is 9. So we just plug in these values. Sum of the data points is 66. We found from step 1, and the n is 9. So 66 divided by 9 is 7.33. Now just note one more thing, that we are able to find the mean without having to put the numbers in ascending order. That means without having to arrange them from lowest to highest. You can do that with the mean. Your data set doesn't need to be ordered. However, to find the median, you do need to arrange the data set, and we will learn that pretty soon after this. All right. Now here we will learn how to find the mean from a frequency table, rather the single value grouped frequency table. All right. First, we'll talk about the single value frequency table, how to find the mean when the data is arranged in a frequency table. And then we'll also talk about how to find the mean uh, if we are given a limit grouped table. All right. So let's look at the steps. It says step 1, multiply each of the value or point by its respective frequency. So we cannot just go ahead and sum up the values because it's arranged in a frequency table. It will tell us how many times a certain value occurs. So you have to multiply the values by their respective frequencies, and only then sum up the values obtained in step 1. After you multiply the values by their frequencies, then you go ahead and sum up the values, and then of course you can divide by the total number of uh, values. That means the sum of the frequencies is what we are dividing by, not the number of points. All right. So let me clarify this. Total number of points, data points, means the the total frequency, or n, the total frequency when it is arranged in uh, in a frequency table of single value grouping. All right, so let's go through an example for that. Now here you see that the data is arranged in a frequency table, but not the kind of frequency table that you've seen before. Previously, when we were creating the frequency table, we had the values arranged vertically, right? So we had different values. The values were maybe 1, 2, 3, 4, 5, 6, and so on. And then the frequencies were listed as 3, 7, 6. I'm just making up these numbers here, right? How many times each value occurs. This is the same thing except that it's arranged, or it's set up horizontally instead of vertically. So let me remove this. All right, so here are some scores given to us: 60, 65, 70, 75, 80, 85, perhaps scores on a test, and the frequency of occurrence of each score also given to us in the bottom row. All right, so that means 60 occurs 1, 65 occurs 2, 70 occurs 6 times, 75 8 times. So it's arranged in a table form, in frequency table form, but you have to know that if the data were presented as raw data, all right, it would look like this: 60, and then 65, 65 would appear twice, and then 70, 70, 70, 70, 70 would occur 6 times, then 75, 75, 75, all that. All right, and then you would be actually, when you're summing up, you would be summing up 6 70s, 8 75s, 2 65s, and so on. All right, we do the same thing here, except we just go and multiply each score or each value by their respective frequencies. So 60 times 1, 60. 65 times 2, 130. 70 times 6, 420. So here we are uh, performing the multiplication of the scores with their frequencies, and then we are summing up. So the value here, 2755, is our sigma x. All right, and the sum of the frequencies, after we add up all these individual frequency values for each score, we have to sum them up, and that is what your n is going to be. And then when you find your mean, you're going to divide 2755 by n, which is 35, for a value of 78.7. All right, so keep in mind when you are working the mean, when you're asked to find the mean from a frequency table, you have to multiply each value first by its frequency and then sum up the result of the multiplied values. You have to sum the multiplied values for sigma x. All right, you cannot just do 60 plus 65 plus 70 plus 75 plus 80, 85. That would be completely wrong. All right, you have to multiply. You have to take into account the number of times each value occurs. So this is very important because I do get answers where students forget to multiply each value by their frequency, and that's why I am stressing on it. All right. We will now talk about the second measure of tendency, which is called the median. The median is the value that occurs right at the center point of an ordered data list. So it's the value at the positioned at the center point of an ordered list, of an ordered set of data. So that's very important. It has to be ordered. So if you are given a list of data set which is not which is unordered, then make sure that it's ordered first. Like it says here, to find the median of a data set, you must arrange the data in increasing order from lowest value to the highest value, and then only you will be able to find the correct value for the median. Then it says if the number of observations is odd in your data list, then the median is the observation exactly in the middle of the ordered list. What this means is if we have an odd number of values, so let's say we have this set 1, 2, 3, 4, 5, 6, 7. All right, 7. We have 7 numbers here, which is odd. And how would we go about finding the median? First of all, of course, make sure that your data is arranged from lowest to highest in increasing order. And then you can locate your median. It would be a value which is right at the center of the data set. All right, the median value in fact divides the data on either side into two equal parts. There are 3 values to its left and 3 values to its right. So in this case, the median is 4. All right, the value that is located right at the center of an ordered list. This is going to be the median. All right, median equals 4. If the number of observations is even, then the median is the mean of the 2 middle observations in the ordered list. What this means is if we have an even number of data sets, so 1, 2, 3, 4, 5, and 6, right? We have 6 numbers here, which is even set of values. Then the median is the mean of the 2 middle observations. Why so? Because the center point in this ordered list, the center point cannot be 4 anymore, all right? Because if you pick 4 for your median, it has 3 numbers to its left but only 2 numbers to its right. It does not divide the data set into 2 equal parts. Rather, the median will be located somewhere in between the numbers 3 and 4. All right, so the median will not be a value in the data set, but it will be between 2 data points in your list. All right, it will fall in this case between 3 and 4. And we will also go over how to find the position of the median, where it will be located. All right, but let's try to understand what it means when we say the mean is the mean of the 2 middle observations in the ordered list. So we have to find a value for this center point between 3 and 4. For that, you have to find the mean, the average of these 2 values around the position of the mean. So all you do is add the 2 values, 3 plus 4, and divide by 2, which will give us a value of 3.5. So in this case, the median will be 3.5. All right. So again, keep in mind, if your number of observations is odd, then the median will be a value within your list, the center value within your list. If the number of observations is even, then it won't be a value in your list, but it will be between 2 values in your list, and you will need to find the average of the 2 numbers around that position where the median would be located, and that would be the value of the median. And then here it says at the end, in both cases, if we let n denote the number of observations, then the median is at position n plus 1 divided by 2 in the ordered list. So to find the position, this is what we do. we take the number of values in our list. So in the first case, in this first example here, there were 7 numbers, right? N was 7. So I'm going to do n plus 1. So 7 plus 1. All right, I'm using this formula here. 7 plus 1 divided by 2 is 4. 8 divided by 2 is 4. And if you count from the start here, from the first number, 1, 2, 3, 4, this is where the median is located. All right. If n is 6, as in the second case, if n is even, so for 6 plus 1 divided by 2, it's 7 over 2 is 3.5, correct? So when we do our counting to get to that number in position 3.5, it would be 1, 2, 3, and then a value between 3 and 4. All right, 3.5. Okay, so that's how we find the median. In the next slide, we are going to go through an example. All right, not as simple as this, uh, little more real life. Now in this example, to find the mean, we have here the data set representing a golfer's distance drive measured in meters is shown below. What is the golfer's median distance drive? So we have here a set of 22 values for the distance drives. And look at the values here, 86, 126, 131. Then we have a 66, which clearly states that, or tells us that this data is not ordered. And the first thing we need to do to find the median is arrange our data from the lowest to the highest. All right, so what we've done here is we've arranged our data from lowest to the highest. The lowest value was 51 and we had 2 of them. So 51, 51, and then the next highest was 66, 66, all the way to 141. So this is an arranged list. We cannot move forward until we order our list to find the median. To find the mean, you don't need to order your list. Even if it is unordered, you can still find your mean. You will get the same value whether you put it in order, or whether you work with an unordered list. But for the median, it's imperative that you order your data from the lowest value to the highest value. Okay, so next step is to find the position. This is a long list. It's not easy to eyeball the exact center point of this data set. So best is to use the formula to find the position. So we have a count of 22 data points in this list given to us. So if n equals 22, which is even, right? N is 22, even value. So the formula is 22 plus 1, all right? It's 22 plus 1 divided by 2. So it's going to be 22 plus 1 divided by 2, which is 23 by 2. And here we have 11.5 is the position. 11.5 is not the median. It is the position in this ordered list where we can find the median value. So let's start counting. Now this 11.5 tells us that the median is going to be between 2 values. All right. So let's do the counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 11.5 will be located between the 11th and the 12th value. So this line is where the median will be located. And since the median does not fall on a number, since the position does not fall on a number, it's in between 2 numbers, you have to find the mean of the 2 values are surrounding that position, around the position. All right, so 85 plus 86 divided by 2, which we've done here. So the middle numbers are 85 and 86. Therefore, the median is calculated as 85 plus 86 divided by 2, which is 85.5, right? Now, the third measure of central tendency is called the mode. And the mode is the value in our data set that occurs most frequently in the data set. So it finds the frequency of each value in the data set. Now, if no value occurs more than once, then the data set has no mode. So if all the values occur once in the data set, then you have to say the answer to what is the mode is going to be. There's no mode. Otherwise, any value that occurs with the greatest frequency is a mode of the data set, right? Now, using the same example that we used for the median, let's try to find the mode of the data set, which represented the distance drives of a certain golfer measured in meters, right? So again, we have an arranged ordered data set, the same data set arranged from lowest to highest. Now, if your data set is arranged from lowest to highest, it becomes very easy to find the mode. All right. So here we see that the value occurring, well, 51 occurs twice, 66 twice, 71 occurs 3 times. So let's mark this for the time being, 71. But let's go over the other 176 occurs twice, 77 once, 85, 86, 96 twice, 101 twice, 126. The rest occur twice. So the value occurring most frequently in the data set is 71. It occurs 3 times. So our answer would be the most frequently occurring value is 71. Therefore, mode equals 71. Now here's an additional example that we'll go through, but before that, I just wanted to say about the mode that it's possible that the mode can be more than one value. So mode can be more than one value. So in our data set, more than one, let me write this first, more than one value. So in our data set, if we had uh, two values occurring the same number of times, then we would have to say mode equal, let's say 71, and then there was another number 76 was also occurring 3 times. Then the mode would be two values, 77 and 76. All right. So if you see two values occurring most frequently the same number of times, then please say that there are two modes, or likewise if there could be three modes and so on. All right. So now let's look at this additional example here. We have two data sets, all right, different values. Uh, in fact, the total number of values n in each of these data sets are different. Here we have 4 times 3, 12 plus 1, 13, right? We have 13 data points in set 1, and we have 10 data points in set 2. And we are going to find the mean, median, and mode in each. So mean is the sum of all the observations divided by the number of observations, which we also called n. So for data set 1, we get a mean value of $483.85, whatever the application may have been. It looks like it was values pertaining to money, so dollar, 300, and so on. So data set 1 had a mean of 483.85. Data set 2, that means we summed up all the values in data set 2 and divided by 10 in this case, we got a mean of 474. Median, which is the middle value in an ordered list. So to find the middle value or the median value, we had to first arrange the data set in order, in ascending order. So for the first data set, it's 400. It was the value right at the center point of the ordered list. So this had 13 values, right? For data set 2, it was 350, all right? And then mode, most frequently occurring value, is 300 for both data sets. So 300 occurred. The was the value that was occurring most frequently in both the data set. So it's the same value for both. We'll now discuss when to use which measure of central tendency, under what situations we would be using the different measures of central tendencies. There are certain situations where one measure of central tendency would prove more useful, more valuable than the others. All right, so let's go through this. It says the mean is used when the variation in the data is not big and there are no outliers. Outliers mean the values that really don't belong with the set. They are extreme values, right? Outliers are extreme values. Somehow they don't fit the rest of the data in the list. All right, so when there is less variation in the data and not too many outliers, no extreme values exist, then mean is a better measure to analyze, to consider. All right, for example, the test score of students. First of all, the range of values that a test score can have would be anything between 0 and 100. As could be just 100 unique values in the list. And most of the scores, the majority of the scores, are expected to be around around maybe 60 to I don't know, 90 perhaps. All right, so there is less variation in the data. The variation, even if there is not as big. And if there are no outliers, then we always talk about the average of the class was 80. All right, that's so when we talk about test scores, we use the measure mean. It's a much far better measure, even though we can provide the median and the mode and so on, but the mean is the most useful measure in that case. The median is used when the data has a wide range of data and may contain outliers. So of the mean and the median is the most robust, and we'll talk about that too. It is not affected by extreme values. So whenever the data set has a wide range of data, there and there's a possibility that it can contain outliers, then the median is a better measure than the mean, because the mean can get skewed by the extreme values if there are any. So to give you an example, let me just label here for the mean. One application would be test scores in an exam. All right, so let me just write that, because I'm going to talk about an example for the median. For the median, if you are looking at the home prices in a neighborhood, right? Home prices in a neighborhood. Now, homes have a wide range of values. All right, in a neighborhood, the home prices can start from 200,000 all the way to $1 million homes. The neighborhood can have home prices in that range. There can be a wide variation in the data. 200,000 house in the same neighborhood, there can be a $1 million house as well. All right, in that case, the median is what we consider. All right, that's why when you look up home prices on the internet in a neighborhood, you can try that. It'll give you the median price of homes in a particular neighborhood. All right, that's because home prices there can be a wide variation in the data. All right, in fact, sometimes a home can get transferred from a father to a son for $1. All right, I've seen that too. Okay, so you can have a $1 home in the neighborhood as well as $1 million home in the same neighborhood. All right, so in those situations, we use the median. Again, you can also look up salaries at a certain company. All right, salaries can range from an entry level person can be can be paid maybe $36,000 to start with, and on the other hand, the corporate CEOs, they are probably getting paid in millions. So that's a wide range of variation in the data set. In those cases, they always give us the median salary at a certain company, perhaps. All right. So those are the situations where median is a more reliable, better measure than the mean is. And we will also see that the median is most robust, meaning that it will not be affected by outliers and extreme values. And in the next slide, I'm going to show you that to you, prove that to you with an example. The mode, which just tells us how frequently a value occurs, or the value that occurs most frequently, is used for qualitative data. Now, know that for qualitative data, the only measure of central tendency that is applicable is mode, because qualitative data is data that comes to us in the form of names, and we cannot find the mean of names. We cannot find the mean or the median of a bunch of names, right? It doesn't make sense. We cannot perform mathematical operations for qualitative data. So the only measure that is applicable for qualitative data is the mode. We can only create frequency tables and see how often a certain response occurs. A certain value, which is a categorical value, occurs in the data set. Let's talk a little bit about the distribution of the data. All right. Now, if we have a situation where the median and the mean are exactly or almost the same, then we have a symmetric distribution of data. Now, this curve actually is a superimposed curve on a histogram. All right, remember we created histograms in the previous chapter when we were organizing data, where we had our our rectangular bars. All right, and when we superimpose a curve over the top of the rectangular bars, we get what's called a curve. And this curve tells us about the distribution of data. Now, when the mean and the median are the same or almost the same, then we get what is called a symmetric distribution. That means this is the center point here. This is the center point. The mean and the median are the same. We have an equal proportion of data on both sides of the center point. That's what a symmetric distribution means. That means half the data lie to the left of the center point and half the data lie to the right of the center point. If the median is less than the mean, that means the mean is higher than the median, then we get what's called a right skewed distribution. What is a right skewed distribution? It is when we have a higher concentration of data towards the left. As you can see, the data has peaked at the left, more towards the left, and then it drops with a long tail to the right. Right? The curve, if you look at the curve, the the data that the most of the values are located to the left of the center point. There's a higher concentration of data towards the left of the mean, and we have less concentration towards the right. Okay, that's a situation which is called a right skewed distribution, and that happens when the median is a lower value than the mean. Median is less than the mean. So let me just write that here. So in this case, the median is less than the mean. Less than the mean. The left skewed distribution, on the other hand, is when we have a higher set of values concentrated on the right hand side of the mean. All right, so you see over here the curve peaks towards the right, and it has a long tail to the left. So if it has a long tail on the left, we call it the left skewed curve. A left skewed curve will have a higher peak towards the right, whereas a right skewed curve will have a long tail to the right and it'll peak to the left. All right. So in a left skewed curve, what happens is the mean is less than the median. The mean is less than the median. Or we can say the median is greater, or the median is greater than the mean. Is greater than the mean. And in the case of symmetric distribution, the median and the mean are equal. Median equals mean. All right, so you have to remember this, because you can get a question where we ask whether the distribution is right skewed or symmetric or left skewed, and you have to give an explanation for your choice, right? A couple of slides back, we had said that the median is considered the most robust of the three measures of central tendency. So of the mean and the median is considered to be most resilient, or also robust is the word. All right, so let's go through that with an example. Now, what do we understand by resilience or robust? That means it's not affected by extreme values, in the data set. All right, so we have a set of numbers here: 1 2 3 4 5 6 7 8 9. All right, we have 9 values here. If we find the mean of these values, we get a value of 5. So the mean of these 9 numbers is 5. If you find the median, right, of this list, again, make sure first that they are arranged in ascending order from lowest to highest, and then the value right at the center is 5, correct? That's the median. So in this case, the mean and the median are equal. All right, that means it's a symmetric distribution, in other words, what we just saw in the previous slide. Mean and median are equal. All right, now in the next situation, what I do is I have my 1 2 3 4 5 6 7 8, and then I change the 9 to a 99. That means I introduce what's called an outlier value. See, outlier value, an extreme value that does not really belong with the other numbers. It's way off from the other values here, right? 1 through 8 are close to each other, but 19 is way out. All right, it's much higher than the numbers that we see here. It's an outlier. And then now we again calculate our mean and median. The mean, once we get this 99 in our list, becomes 15. It was 5 before. We changed only the last value was changed, made to an extreme value, and the mean change jumped up by 15. So that means this value, this 99, affected the mean. The mean got affected by an extreme value, the outlier value. The median, on the other hand, if you calculate the median, we still have 9 sets of values. All right, we still have 9 values in our set. The midpoint is still 5. That's the median. The median didn't change, right? The median still stays at what it was before the outlier was introduced. And it stayed the same after the outlier was introduced as well. All right. So that's what we mean when we say that the median is a robust measure, a resilient measure, because it's not affected by extreme values. Extreme values will not change the median in a list. All right. So that completes the study of the measures of central tendency. The next few lessons will be on the variations. All right, variations within a list of values.